In this tutorial we're going to make a command called image info. So we need the count and the vector of the arguments that we're given. If there's fewer than 2, we'll show some help. If there's greater than or equal to 2 arguments, we'll process each of the files that's been given for our command. Let's create a directory called C, since RISC OS doesn't use file extensions, and we'll save our source file called info, ready for the compiler. Next thing we're going to do is create a makefile. That's because we're going to end up with several source files to make one executable, and rather than having to do them all by hand, we can let the makefile do the work for us. If we use the shared makefile system that comes with the DDE, we can save ourselves a lot of typing, and we don't really need to understand how a makefile works. Give it a component name, so that's the executable, and then we need to give it some object files. And in this case we've only got one so far, so info.c produces the object file info.o. Then include the C application shared makefile, which does all of the rest of the work for us. Save that. Then we have a couple of obey files. These are just to avoid having to launch AMU by hand. And also when cleaning the project, there's a utility called strip depend which removes dependencies which are saved in the makefile. So other than that, they don't really do anything significant. Close all that. Remember to run the setPaths application, which sets up a load of system variables. Then you can run the obey file, and there we go. The shared makefiles have picked all the source files, linked them together, and if we type our new command image info with a few arguments, it'll process each of the files that we've given. Now we're going to expand on our main program a little bit. So for each argument that we're processing, we're going to open it in read-only binary mode, just using fopen. So if we get null back, then the file was not found. And if we get a file handle back, the file was found. Then we can read in the first few bytes from the beginning of the file, which allows us to search for any magic words or signatures at the top. But by far the simplest way of finding out what type of file is just to look at the file type that the OS has stored. In the filing system, each file is given a file type, and each one has been allocated a unique number. So for a sprite, that's file type FF9 hex. So we can just look that up in a switch case statement and process the sprite accordingly. To read the file type, we use the system call osfile, and read and code 23 gives you the catalogue information for a file. So let's call that system call using the swix function in C. And the two input registers give us the reason code and the file name, and we want back the length and the file type, which is in register 4 and register 6. So 23, the file name from the command line, and then return 2 words which are 32-bit integers, giving us the file length and the file type. Save that. So now we're going to process the sprite and process the JPEG. Alternatively, we can deduce the file type by looking at the header. So if it's got JFIF or FFD8 FF at the beginning of the file, we know that it's a JPEG. For now, each of the handlers does nothing. Those are just dummy implementations. So we'll need to add those to our makefile so that we've got 3 object files in total. One for info, the JPEG handler, and the sprite handler. save the updated makefile, and rebuild the project. Obviously we've got some warnings for the variables that we haven't used in the 2 dummy implementations yet. The final bit of code we need is something to decode the sprites and JPEGs. We're going to load the whole sprite file into RAM, and for that we need to set up a sprite area of size the file plus 4 extra bytes. Now with RISC OS, all of the sprites are manipulated using the system call sprite op, and again, like OSFile, there's many sub-reason codes here, and the first thing you need to do is initialize the sprite area so that it's empty. So that's reason code 9, and we set up the area with the size of the area in bytes that we've just allocated, and the magic number 16, which is an empty control block size. We can get some of these magic numbers from another header file which defines all the various constants to do with sprite manipulation as reason code number 9 to clear the sprite area, so we're going to use that one first. Notice that there's a 256 added to the reason code, and that's just to denote that the sprite area is in the user allocated memory. So if that sprite call was successful, we can then load the file off disk, and here we're checking the return result from Swix. So if we get a null back, then that means there was no error. So that was successful. So our next sprite op is loading the file off the disk. That's reason code number 10. So this system call has 3 input registers, 0, 1 and 2. There's the 256 again to denote that our sprite area is in a user allocated piece of memory. And we'll grab the sub-reason code from the header file to save us typing it in. Give it the sprite area and then the original file name passed by the command line. So if that returns non-null, that means it got an error and we have an unloadable sprite. Once we get into the sprite file, we can just iterate through each of the sprites within the file, because you can have multiple sprites in one sprite file. For this, we increment R4 each time round a loop to give it the sprite number until we get an error back. So our loop looks like while error is null, keep asking for another sprite name, terminate the sprite name so that it can be used as a C string, and then use another system call to read information about the sprite, and that will give us the width and the height for a given named sprite within the sprite area. And then each time round the loop, get the next sprite in the sprite file. So save that. And lastly, the equivalent code for a JPEG. Now you can only have one image in a JPEG file, so this one's somewhat simpler, and we can also make use of the JPEG system call to read file information directly. So all we need to do here is JPEG file info, give it some operational flags. Here we want the dimensions, so we need to set bit 0, so 2 to the power of 0 is 1, the reason code there is 1. Give it the file name and then return X and Y in R2 and R3. Recompile our project. That was successful, and it's produced a new command application called image info. We can now launch our program called image info, and I've got a couple of test images called mytest1 and mytest2, one of which is a sprite and the other of which is a JPEG. And that's our application complete.